Welcome back to our Lidar Basics series. This is part 3. We're building a data project in TerraScan. This is most useful for bigger data sets. Once again, this is Emily, and yeah, let's get started. So we're back in Microstation. Here you can see our Lidar data is back in one class, which we can double check by going to our statistics. So no points are in any other class. So our first thing to do to set up a project is we're going to go into our level manager. Levels in Microstation are similar to layers in other GIS technologies. You can use different levels to place different types of data. So we're going to click on our level manager, which we can get to by going to the home and then to the level manager button, or search in the ribbon level manager. And this is our level manager window popping up. You can see all the different levels that are here. Most of these are inactive. So to get a new level, you click on level, new. I'm going to name this blocks because we're going to be tiling. And another step that you can go into is the level display. This will allow you to view what levels you have, so what layers in essence you have. And down here, there's my blocks level. Now to activate it, you can either double click or right click, which is what I did here, and set active. This is an important step. You can also change the color of it. Here I'm changing mine to green. Another way to activate the level is by going up here and checking which level you want. So once you've got your levels activated, we're going to double check to make sure TerraScan is loaded. You should see a toolbar, something like this, and then the TerraScan toolbar. If your TerraScan is not loaded for any reason, we're going to go into MDL applications, which we've done in a previous video, so I'm not going to go into further details on that. But make sure it's loaded up. Now this area is quite a small area, but if we had a much larger data set, we would want, this is where loading every 1,000th point would be useful. So you can just grab a fence. What I did was go into fence tools and placed a fence around my area of interest. And then after that point, you can close the points or keep them open depending on how large your data set is. An alternative to placing this fence here is you can just type into your search ribbon, place block, and you can outline that exact same area with the orthogonal block. Click into element selection and it'll make your fence disappear, and then you can close your points after this point. We don't need to save these ones because I already have them saved, and now you have an empty block. So now that we have our block, we're going to go to Define Project. I'm circling this little button because that's probably what you'll have to click and hold. Ooh. So it's right here on mine. You're going to go down into Define Project, and you should see this window pop up. We're going to File, New Project to start. So you can see we need to give it a description. So I'm calling mine Ursa, which is the area, and tutorial. We have to define the storage. So I'm in LAZ 1.3 or LAZ. We're going to define our block size. Standard block size is often 1,000 meters and 20 meters as a buffer on either side. It can vary depending on your data density though. Up here, we're going to save our data in our separate directory. So I already have a folder created, which I'm going to navigate to, if I can find it. My project for TerraScan, here it is. Okay, and another thing you can do is you can load your trajectories automatically and select the directory where your raw data might be. I'm not going to do that for the purpose of this, but press OK. Okay, so you now have your project window open and it's all set up. So we're going to double check to make sure that our levels are on to our blocks that we just created earlier in this video, and which we can see it is. So we're going to look for a tool called AccuDraw, Toggle AccuDraw, which can be found under Drawing Aids right there, or Home in this little area. Or alternatively, you can always use the search function. And see, you've got that little window there. It shows the XY point of wherever you're toggling towards. So we're going to place our first block. We want our block to be orthogonal, so that was the tool Place Block, which you can just search in the ribbon. You're going to place the corner, and in our Toggle AccuDraw, we can define how big we want the block. So I'm doing 1020 meters. So you can select Element Selection and move around that box. I'm moving it to the corner here. So we've got our first bottom left-hand corner tile. Now we're going to go to this tool. It's under Home, and it's called the Array tool. It used to be formerly known as the Construct Array. So we want to define our row and column size. So I'm going to guess that I have 5 rows and 5 columns, knowing that my square is 4,000 by 4,000 meters. So if it overshoots or isn't really where you want it, you can just element select, adjust it, and delete any that are a little bit too big for your data, any that you don't need. So I'm going to go through here and delete quickly. Yeah, so all good. That's exactly what I want. I also deleted my original frame. So next, we're going to want to name our tiles. So we're going to write in the text styles in our search ribbon, and this allows us to change what our text looks like, basically. So we're going to start with uppercase. That's a pretty good default. My blocks are 1,000 meters, so I'm just going to do a smaller text, so 100 by 100. And then we go up to our search ribbon again and type in place text, and we're going to name it. So I'm going to name mine U20, so Ursa 2020 01. You want that number to be big enough that it'll account for however many tiles you might have. So we could individually name it, or we can do the copy increment tool. This will just make it go a little bit faster, so you can click on it and drag it to the right and click in each box, and then it'll name each one. So that's if you want to manually do it. So after we've manually labeled ours, we're going to want to add the blocks to our project. So we're going to select the entire area with our element selection tool. You're going to go into your project window here. We're going to click on block, add by boundaries. And it's going to come up with this window. So this is an area where if you had thousands of blocks, you could opt to automatically name it, more or less. We have manually labeled it because this is not that large of an area. But if you wanted to do something, you could do a file prefix of U20 and it would name them the first number and by the order that it's showing here. So whatever order you select. But we're going to do selected strings because we've already manually labeled it. And there we go, they're added. So all 16 blocks, and you can see the numbering system there. So before we go anywhere else, it's always good to save our project. So we're going to save our project as and locate where we want to save it. So I'm going to do in my project folder, and I'm going to call it Ursa tutorial. Press save. And our next step is to load our LiDAR data into our project. So we're going to import points into project. And here is where we have to find our raw data that we're putting in. So here's my Ursa clip practice, which is my raw data. And then you get this window popping up. So here we've got the right format. We're going to ignore our outside blocks. For our block overlap, we're just going to duplicate points because we do have block overlap. And here we're going to use from file because I only have one single file. But if you have multiple files, you could increase by file. So that's another option there. And then press OK and time to wait. This can take a while, so be prepped for that. So we've now imported our points into our project, which is what this window here is showing. So I'm going to close this out. I'm going to save the project, so File, Save Project, very important. And just to really check to make sure that our tiles or our blocks have properly been loaded, we're going to find where we saved our project and our tiles, and here we can see all 16 tiles are in place, so it worked great. So now we can open an individual block by putting File, Block on the TerraScan window and clicking on that block. So here I've got one single block open, zoom in, and that just allows us to view a much smaller size of data file at a time. You can open another one again by File, Open Block. So now that we know how to do that, we can also do similar functions. So this is again the profile viewer, and you can do a small slice in the individual one. And yeah, so this really just helps with data control, trying to minimize how much data and computer RAM you're using at a single time.